Okay, here is problem 22 on page 61. This is homework for Monday night. So number 22, page 61. The question is about two runners approaching each other along a straight track. They have constant speeds of 4.5 meters per second and 3.5 meters per second when they are 100 meters apart. How long will it take for the runners to meet, and at what position will they meet if they maintain these speeds? So the first thing we're going to do is draw a picture. So here is the beginning of runner 1, and here is runner 2. So runner 1 headed off in this direction, runner 2 approaching in this direction, and they are 100 meters apart. Always draw a picture for your problems and label these things. So here we have runner 1 is going 4.50 meters per second. That is her average velocity. And she's going in this direction, and she's going in this direction at an average velocity of 3.50 meters per second. The way that I've always approached these problems is to look for something that's equal in both cases. So is the distance that they're running going to be equal? No. Is the velocity that they're going to be? No. Then what's the other variable in a distance, rate, time problem? It's time. So the time is the same thing. So here's how you have to set this up. Let's assume that this runner runs to about here. Okay? You can see that that's roughly where they're going to meet. This runner is going to be running in this direction. This person's a little slower. So this person's going to be able to run further in the same amount of time. So they meet right here. Okay? We're going to call this distance that this runner calls, let's call this, in these problems we're going to let x be the distance. Alright? And in fact I'll use, we'll just use x. Okay. And then if that's the case, then how far did this runner have to do? Don't pick another variable. Look at the problem here and realize that this runner is running not 100 meters, but less than 100 meters. And how much less than 100 meters is she running? Well, she's running x less than 100 meters. So she's running essentially 100 less x. Now we'll be able to set up the problem. So the basic problem we have here is that the rate, or the average velocity, is equal to the change in x divided by the change in t. Okay? So if we wrote an equation for each problem, they obviously have different velocities, v1 and v2, and this person runs this x and this time. Now, this x is really not x, it's 100 less x, so we're going to have to write v1 equals 100 less x over t, and this one is v2 equals x, basically, delta t. So we're going to manipulate each of these equations to solve for t. So, and at the same time we're going to put in our values for the velocities. So this becomes 4.50 meters per second times time equals 100 less x. And this one becomes 3.5, and again I'm treating these as two as on separate parts right now. 3.5 times t equals delta x. Solve for t, so that means t in this case equals 100 less x over 4.50, and this t is equal to delta x, or x over 3.5. Okay? Now the t's are equal, right? So now we can write one equal sign here and say x over 3.5 equals 100 minus x over 4.5. Let's solve x. So what we have to do then is essentially cross multiply to solve for x. So I'm going to multiply this across. 4.50x equals 3.50 times 100 minus x, all of that in parentheses. Let's distribute this. That becomes 350 minus 3.50x. 4.50x equals, and then we work one more step. We see that if we add 3.5 to both sides, this becomes 8.00x equals 350, and then x is equal to 350 divided by 8.00. 350 divided by 8 is equal to 43.75. So the distance x in our problem is 43.75 meters. Let's go look back up here. So this distance right here is 43.75 meters, and that means that this young lady ran 100 minus 43.75. Where's the answer on this? Answer. Second answer, I don't see it. 43.75. And so that turns out to be 56.25. And that's in meters in both cases. Okay? So we've just answered the first question. We actually haven't gone back and answered the time question. So we could write down here, the runners meet 56.25 meters from the left-hand runner's start. Okay? How do you solve time? The way I always teach students to solve for time here is, oh, by the way, I didn't show that on the video here. You write out a sentence to show me that you have the answer. And so that is part one. And then how long will it take? Here's what I tell my students. Pick the easiest equation. Which is an easier one to solve? That one or that one? Well, that's the easier one to solve. So we're going to solve t equals x over 3.5. So t equals x, and we said that this gal's x is 43.75. And her speed was 3.5. Let's see, that was meters, and that's meters per second. So the time, 43.75 divided by 3.5 equals 12.5 seconds. So 12.5 seconds after the two runners start is where they're going to meet after starting. Okay? That's how I would like you to solve a problem. You can see that that took an entire page of work. I'm not going to ask you to skimp on paper. Please, please, please show the work that you do for me. Okay? Thank you.